Okay, so yeah, we are online meeting today. We are talking about chapter 13. So I'm going to walk through two questions step by step with you guys. Okay, so the first question is analysis predicts that the likelihood of a great economy is 60%, while an average and poor economic states share 20% probabilities each. It is predicted that in a good economy, the stock will provide a 15% return, a 5% in an average economy, and a 10% return in a poor economy. Calculate the standard deviation of the stock. Okay? So I'm going to show you how this works. Just give me 1 second. I need to do this. Okay, so in this question, you were asked to calculate standard deviation. Okay? In the stats course, you have learned how to calculate standard deviation, right? So the way you do it is, let's say you have observations, right? You have some observations, x1 equals 2, x2 equals 3, and x3 equals 4, right? So in the stats course, suppose that you have 3 observations, okay? These 3 observations happened, right? They are really happened. You measure it or whatever, you collected the data. So each of them are 100% outcome, right? It's a real outcome. It's not a possible outcome, okay? So in stats, then, when we do the standard deviation, first we calculate what's my x bar, what is my mean, what's my average. So then you go by x1 plus x2 plus x3, and you sum up all these numbers divided by the number of the observation, 3. So you should get 3, right? Okay, so that's the first step. You calculate the mean, right? So to calculate standard deviation, you first need to calculate the variance, okay? Variance, because standard deviation equals the square root of the variance, okay? So standard deviation equals the square root of the variance. So how do you calculate the variance, okay? So first, you calculate how, okay, I guess I can write down the formula. So for variance, so that equals, it's a sum of your observation deviate from the x bar, and then that's you compare each observation with your average and take that difference, and you do a, what? Okay, you do a square, okay, and then you sum them up. In this case, my I equals 1, 2, 3, right? So I have x1, x2, x3, right? So this sum is the sum of 3 terms, right? And then this has to be divided by n minus 1. Okay, this n is the number of observation. And the reason why it's minus 1, because you lost the freedom, right? Because the 3 observations, right? You use these 3 numbers to calculate your x bar, right? So once in these calculations, x bar is involved, you lost the freedom because you use the 3 together to calculate the x bar. So you lost the freedom, okay? So this is how you do it when you are doing the stats course, right? The standard deviation. Note each of these observation, x1, x2, x3, these are the actual observation. They actually happened, okay? You can think about this is the heights of your 3 brothers, okay? So in your family, okay, let's say in your family, you measured the heights, right, of three brothers, right? So x1, x2, x3. So, and those are the real heights, right? It's not the possible heights, right? So it's not like your parents is going to planning have three babies, right? You are thinking about what are their possible heights, right? Maybe maximum like 20% taller than the father, right? Minimum maybe you know what I'm saying, right? So this in the stats courses, the things you are learning, those are the actual observations. Okay, so this is really important. In this situation, we are saying that the economy has different states. States one, so that would be let's say great, right? That's a state, great. So if the state economy state is great, so in a good economy, you're gonna have a 15% return. Okay. If the state two is that average, right? Average. So the average, if it's average, your return will be 5%, 0.05. State three is a poor economy. Well, if the economy is poor, you're gonna have a negative 10%, losing money, negative 0.1. Okay, so this is the return. Now, can anyone tell me, do you think these three numbers will happen at the same time? 0.15, 0.05, negative 0.1. So that's the three numbers, right? Do you think they will happen at the same time? No, right? Definitely not. Because only one of this can happen. Well, because economy cannot be um, great, average, poor at the same time, right? So economy has three possible states, okay? But when they turned out only to be one of these, right? It's just like when you are flip a coin, right? So when you flip a coin, you can either get a head or tail, right? But you cannot get both head and tail at the same time, right? So your probability of getting a head and tail are equal, 50% when you're flipping a coin, right? The same idea when you throw a dice, right? So you can possibly get 1 to up to 6, right? But you cannot get all these six numbers at the same time, right? So that's what we are saying here. These are the three possible outcomes, and only one of these will actually happen, right? So, and then we know the probability, right? Some outcomes are more likely to happen than the others, right? So now we use the probability. So 60% for the good economy. And the remaining 40% is split between average and poor, so 40%. So are we clear with this? Because this is really important. So give me a thumb up if you are clear with what I'm saying so far. Okay, thank you, Keaton. Godfrey, is that clear to you? Okay, good. So now, when I'm using this three, when I'm calculating the average, it's not really average. It's just not accurate to say that way. We will say expected return. Okay, expected return. So taking the full picture, you consider the weight, the probability. Okay, so you apply the probability as a weight to each return, so you can get a weighted average, right? Expected return. So the way you do it is you use 60% times 0.15, okay, plus 20% times 0.05. Okay, and then you use the remaining 20% probability times negative 0.1, right? So note that this probability has to add up to be 100%, right? Because one of these outcome will happen, right? So when you have these probabilities for different states, you add all this probability up, they should be equal to 100%, okay? So then you can calculate this. Let me see what this should be. This one should be 0.09 plus 20% is 0.01 and minus 0.02, right? So I should get 0.08. Is that correct? So the expected return is 8%. Is that right? So that's what I got. What do you get? Okay, good. Thank you, Keaton. So that's the 8%. You can see that, well, the best outcome is 15%. The worst outcome is negative 10%. The mediocre is 5%. So when you think about the expected return, so on average, if you're playing this, let's say if you keep playing this game, right, many times, the expected return, okay, should be 8%. Okay. If every year you have the same return and probability, if you do it for like 100 years, okay, so on average, every year your return should be 8%. Okay. That's the expected return. But the real return will be one of the three outcomes. Will be either 15% or 5% or negative 10%. You will never get 8%, right? That's the expected return, right? But the actual outcome will be either one of the three, right? Okay, so with this, now let's calculate the standard deviation. So you can think the expected return is kind of like the mean, right? But you know that it's different because when you calculate the mean, each observation has the same weight, right? In this case, each observation got a third weight, right? The weight is a third for each observation. But in this case, the weight is different, right? The weight is different. So expected return is not the same or equivalent to the mean, okay? So now let's calculate variance, okay? So this variance is calculated different from the stats course. So that equals, again, you go from I to 1 to 3, right? 3 observations. So then you go with the return R, right? R is possible. Ri, okay? Ri minus expected return R bar, okay? And then you square, okay? And now should you divide it, should you go by n minus 1? So this is the part you maybe find confusing, right? So you don't go n minus 1, okay? You don't do that, okay? You don't do that. So what you do is you go by pi, okay? So you use the probability as the weight to apply it to this squared, the different squared. Does this make sense? Keaton, Godfrey, Cheryl, does this make sense? So I really want you to see the difference between when you're calculating standard deviation of a stock using the possible outcomes versus in the stats courses, you calculate the standard deviation using the actual observations, okay? So the formula is different. So here, you're not dealing with n minus 1, okay? Don't be confused with that. Does this make sense, everyone? So give me a sum up if it makes sense. Okay. Oh, that's good. So now let's keep going. So when I equals 1, so you go P1 divided by R1 minus R bar square. So instead of say 1, how about we say grade, right? PJ, RJ, grade. And then I add average, PA times RA minus R bar square plus poor, let's use RP, GP, okay, poor RP minus R bar square, okay? So that would how you write this out using this formula. So the probability for the great, good economy is 60% times when economy is good, the return would be 0.15 minus expected return 0.08 square plus when the economic state is average, the probability is 20%. Okay, and the return would be 0.05 and minus 0.08 square. And plus, when economy is poor, you use 20%. It's the same 20% times important. This is a negative number, right? You go negative 0.1 minus 0.08 square. Okay. Why don't you quickly do a calculation? Tell me what's your result here. So quickly use your calculator, do this calculation, please. See what you got. Okay. Did anyone get the result? Let's see. 0.0096. Okay, did anyone else get the same result? Yeah, that's correct. That's what I got too. So 0.0096. Are we done? What is this number? What are we calculating so far? Did we finish this question? The standard deviation is 0.0096. Yes or no? So what I'm doing calculating is called variance, okay? So if you see this sigma square, this is called variance. So standard deviation is this guy. So you have to take the square root of this number. That's your standard deviation. Okay, so take the square root. 0.979. Does this make sense? Yes, because when you do this, when you are using this equation, the first step you are calculating the variance. The standard deviation is the square root of the variance. Okay, good. Can I move on? Give me a thumb up if I can move on. Okay, good. So that's this question, right? You have to know how to do this, right? You have to know. I guarantee that there are going to be questions like this. Okay, now let's consider an investor is considering a portfolio mix of 70% of stock A and 30% of stock B. Stock A's return are expected to be 20, 10, 8% in good, average, and bad economy, respectively. Stock B's return are expected to be 25%, 2%, and 15% in the three conditions, respectively. So the probability of a good return, 60%, and the other has 20-20, okay? Given this information, calculate the standard deviation of a portfolio. So let's take a look at the previous question. The previous question is to calculate the standard deviation of the stock. So just a single stock, right? We are only here in question one, we are only dealing with one stock, right? But if you know just a little bit about investment, you know that people build a portfolio, right? When they spend their money, they won't spend their money on just one stock, right? Because it's too risky, right? So you have to build a portfolio by different stocks from different industries, right? Put them into your portfolio, right? So this question, the second question is asking the standard deviation of the portfolio. Okay. My question for you is, okay, why are we interested in the standard deviation? So the first question, we calculate standard deviation of the stock, right? The second question, we are calculating the standard deviation of the portfolio. My first question is, I'm teaching you how to calculate it, but I also, most importantly, I want to understand why it's important to know this number. Okay, can you tell me why we calculate the standard deviation? What does it say about the stock? What can it tell us? What can we learn from the standard deviation? It's easy to understand the expected return, right? That's just you are expected to earn this much return, right? So with return, now what do you think standard deviation is measuring? Yeah, the risk, right? Standard deviation is the risk. Very good. Okay, so it measures the risk. So in this question, we have learned that the expected average, okay, if you draw a picture of the normal distribution, okay, so the expected average, the expected return is, what is that number? 8%. So if I draw a one standard deviation range, in this range, one standard deviation, 1D, right, plus. We calculated the standard deviation is 9.8%. So 8 plus 9.8. So here will be 17.8. Okay, so this point is 17.8, and this point is going to be negative 1.8. Okay, so we are saying that between for the stock in the year, the chances there are 68%. Okay, so this in the middle is a 68%. This 68% range, 68 probability, the probability of 68%, your return will be between negative 1.8% to positive 17.8%. If your standard deviation is larger, did you see they spread out wider, right? So that means it's the volatility, right? You can go from a very big negative number to a very positive number, right? So, think about flipping a coin, right? So you could get, let's say you pay $1, right? If you win, flip a coin, you win, you get $2, right? If you lose, you get nothing, right? So that return is zero. What is the risk, right? The risk is pretty high. The volatility, right? From losing everything to winning doubled, right? So that volatility is a risk, right? So consider this picture. But if you think about a different picture, like if it's narrow and sharp, right? If it's narrow and sharp, so your actual result will be just around this area in a narrow range. That means you have more certainty, right? You have more certainty. Therefore, you have less risk, right? So when you have precision, right? This is called precision, like a high peak, narrow curve. Okay. So that's a small standard deviation. Okay. You have more uncertainty. So lower risk. But if you take a look at this guy, okay, if the peak is lower but it's wider, then the return can be anywhere, right? It's very wide. So in that case, the risk is higher, right? Okay, so knowing this is important. So since you have learned from question 1 how to calculate the expected return and the standard deviation, I want you to calculate the expected return of A, okay, and the standard deviation A. And then I want you to calculate expected return B and the standard deviation B. Okay, I have shown you how to do it in the first question. Now it's your work. So please do it, okay? So I want to do this. I want you to do this. And tell me your result once you have it in the chat, okay? So please do it now. Once you have the result, please throw it into the chat, okay? So I need to know 4 numbers. For A, I need to know the expected return and the standard deviation, okay? For B, I want to know the average return. I want to also know the B's standard deviation, okay? So make sure you all work on this, okay? So I'm going to drink some water. I gave you 10 minutes to work on this, okay? Did you guys get the result? Not yet. Did anyone finish the A or B? Okay, thank you, Dante. A 是 A is 0.156 standard deviation days. Okay. Thank you, Dante. Did anyone else get the same result for A? Point 146. Okay. Seems like we are getting different results, right? Okay, so I will do this. So let's take a look at A. So for A, so I will go weight good times A good plus weight average, sorry, probability, P. Probability average, go with A average plus probability poor, bad, probability bad, A bad. Yes, yeah, 6.25 for standard deviation. Congrats, Godfrey. You are absolutely correct. That's the answer for the portfolio. So you are ahead of the game. So A bar equals, so probability of good condition, right? For A, we are talking about stock A, right? So for A, the good economy 60%, 2020. So this is still 0.6 times A, where is A's return? This times 0.2 plus 0.2, 20% times 10% plus 20% times 0.08. Okay. So when I'm calculating this, this would be 0.12 plus 0.02 plus 0.0. So that's 0.016, I think. This gives me okay, 4.156, right? So that is the A. Yeah, that's correct. So that's A. Okay. And B, what is B? Right? B equals similar idea. So probability is the same, but the return are different. So this time we use this 0.25, okay, and 0.2 negative 0.15. And I'm going to use the probability 0.2 plus probability 0.2. Okay. So here, this one is going to be 0.15. This one is 0.04. And minus this one is going to be 0.03. So the average, the expected return for B would be 0.16. Is that correct? For the average of B, did anyone get this number? For the expected return of B should be 0.16. Is that correct? .124. Okay, let me check mine again. So that's gonna be 60 times 20%. Oh, sorry, it's 2%. I thought it's 20. My bad. So that's gonna be 0.2. So this one, I need another 0 here. Okay. So this will give me, yeah, you absolutely 0.124. Yeah, thank you guys. So now you know the expected return of A, you know the expected return of B. What about the expected return of the portfolio? Well, the portfolio have 70% A, 70% A and 30% B, right? So if there's $100 to invest, I spend $70 on A and I spend $30 on B, right? So this weight is about how you spend your money, how you allocate your fundings, right? So I allocated 70% of my fundings to A, so 30% to B, right? So now think about the portfolio, right? The portfolio's average. So that's going to be the weight on A times A's expected return plus the weight on B times B's expected return. So that's going to be 0.7, 70% times 0.156 plus the other weight is 30%, 0.3 times 0.124. So now this one gives me what? So the first term is 0.1092. The second one is 0.0372. So when I put them together, I get the portfolio's average 0.1464. Good job, Godfrey. Yeah. So the average, we know the average of the portfolio, right? So how to calculate the standard deviation of the portfolio? So that's easy, right? So think about the standard deviation formula, right? I just introduced that. Consider portfolio as one thing, right? So there is two term, I equals 1 to 2, right? And here, you are going to have different, states, right? Different states, I to 1 to 3. So you're going to think about the portfolio for each state. Okay, RPI, portfolio for each state return, minus this expected portfolio return and the square times probability I. Okay. So we're saying, you know, the expected return of the portfolio, right? This one is 0.1464, right? And now for each state, you would know the actual portfolio return, right? So how do you know that? Can anyone tell me how much the actual return would be when the portfolio have a good economy? If it's good economy, what is the return of the portfolio? RP. Well, you apply the weight, right? Weight A times A's return when it's a good economy, plus weight on B times B's return when it's good economy. So 0.7 and 0.3. And when it's good economy, the return for A is 20%. When it's good economy, the return for B is 25. So this one gives me 0.14 plus this one gives me 0.075. So I should have 0.215. Is that correct? When it's a good economy, my actual return will be, the portfolio return will be somewhere between A's return and B's return. So A's return is 20%, B's return is 25%. So my weighted average return of the portfolio is 21.5%. Okay, so this is when the economy is good, right? So then you can keep going. What about the economy is, if the economy is average economy? So still the weight is the same, 70 and 30. Now, okay, sorry. A's return when it's average, the middle number is 10%. B is 2%. So this tells me 0.007 plus 0.006. So I have 0.076. Okay, so when the economy is average, the expected return of the portfolio should be 0.076. Okay, so make sure I highlight these numbers. And now when the economy is bad, again, 70%, 30%. When economy is bad, A has a return of 8%. But B has a return of negative 15%. So this one gives me 6 minus 0.045. Yeah, that should be right. And then I get a 0.011. Okay. So when economy is bad, the portfolio will have a return of 1.1%. When the economy is average, it's 7.6%. When economy is good, it's 0.215%. Okay. So now, when you are using this equation, there are three terms. Good, right? There's three terms. When it's good, the probability is, oops, what happened? Where's my, okay, sorry. When the economy is good, the probability is 60%, and times the portfolio's return when it's good is 0.215 minus the average. The average, we calculated the average, right? 0.1464%. And then you add, right? You add. The second one is the average. Or probability is 0.2 times the return will be, when it's average, that will be 0.076 minus 0.1464 square, and then plus 20% times the bad situation, the portfolio expected return would be 0.011 minus 0.1464 square. And so, and this, you do the calculation, okay? And then you take the square root, okay? You take the square root. So if you get it correctly, your portfolio standard deviation should be 8.65%. Did anyone, I know Godfrey got this number. Did anyone else get this number? Did anybody else get a number? Are you with me? Okay, good. Okay, thank you, Dante. Okay. Do you guys have any questions on this? Any questions? If you understand everything, give me a thumb up. Thank you, Kaden. Thank you, Dante. Cheryl, thank you. And Godfrey, yeah. Okay, thank you so much. Yeah. Do you have any questions you want to ask me now about chapter 13? No, if you don't have any questions, the class is dismissed. Okay, and make sure that you do the assignment. And this is our second last chapter, so we're gonna almost done. Okay.